So, do you remember how to graph this parent function? Y equals square root of x. Where do you start with this one? What's the smallest thing I can take the square root of? Even smaller. Did someone say 0? I'm assuming that you did. Good. So, 0 is the smallest thing I can take the square root of. Square root of 0 is just 0. What can't I take square roots of? Negatives. I can take the square root of 2, it's just not nice. But I can do it. But I literally can't take the square root of a negative number without using a whole new number system, which you'll do in Algebra 2. Anyway, so I can take the square root of 0, which comes out to be 0. The next nice number I can take the square root of is 1, and the square root of 1 is just 1. So my next point is just 1, 1. I wouldn't take the square root of 2. I wouldn't take the square root of 3. I can, but they're not nice. The next nice one is 4, right? The square root of 4 is just 2. And I know I run out of room, but the next nice one would be 9, and that would come out to be 3. So I'll just put one more dot. So if you remember from yesterday, this is kind of the basic shape of the square root functions. So remember, this is a hard stop. It does not have an arrow because I can't take square roots of negatives. So it has to start strongly at 0. This side will continue on forever because I can keep taking square roots of positive numbers and they can get as big as they want. So let's just recap also from yesterday. Or maybe we didn't write this down yet. I don't remember. But here is my general form for a square root function. Y equals a square root of x minus h, all under the square root, and then a plus k. So just like yesterday, h comma k is my vertex. Or not my vertex here, it's my starting point. So that point that's normally on 0, 0 is now going to pick up and move to wherever h comma k tells me to go. A is still going to have an effect on the size of my graph. So if it's negative, it flips upside down. And then I think I'm going to talk about that in a minute. So put a peg in that.
K is outside as well.
Yes, K is outside, H is inside. So let's look at something like let's jump to 8. So just like you were doing before, finding h comma k for a vertex, this isn't quite a vertex, but it's still my starting point. Where would that starting point be? It would be at number 8. It's just at 3 comma 4. You still always take the opposite of whatever you see in there with the x. So 3 comma 4. 3 comma 4. So that's my new starting point. I kind of wish we could see both of them at the same time. Well, we kind of can. Here. This is the parent function. It started at 0, 0, then 1, 1, 4, 2, 9, 3 if you want it. 1, 2. So all I'm basically doing is I'm picking up each of these points and I'm shifting them to the right 3 and up 4. Right? There was my initial starting point, and now there's my starting point now. I picked it up and I moved it to the right 3, up 4. Do you see that? So then every other point just gets picked up and moved to the right 3, up 4. So this point right here now goes to the right 1, 2, 3, up 4. 1, 2, 3, 4. This one to the right 3. 1, 2, 3, up 4. And you could do this one too, but you're going to be off your graph, but I'd guess it'd be kind of like there. So then when I graph it, it's the same exact graph. I've just picked it up and moved it. Does that make sense? Is everybody all right? So let's say I was looking at number 10. So if it's helpful for you to sketch the parent function before I even start, so my parent function 0, 0, 1, 1, 4, 2, 9, 3 if you feel like it. So there's my original function. And now I'm going to pick the whole thing up and move it where? Exactly. So my initial point now moves to the right 4 and up 2. Just so happens to overlap that dot, but that's okay. To the right 4, up 2. So I do the same thing with each and every other dot. Right 4, up 2. You're going to move to the right 4, up 2. So here is my new graph. Oh, shoot, yeah. Oh, Miss Sabia, you silly goose. For -2. So there's my graph. Thanks. Does that make sense? Okay, so now let's kind of talk about what happens with that number out in front. So, jump back to number 5. Again, I'm going to sketch the parent function. 0, 0, 1, 1, 4, 2, 9, 3, if you want. Okay, so there's my normal square root function. This time, I'm supposed to graph 2 times the square root of x. Well, all right, let's see. I'm just going to plug in some values and see what comes out. If I plug in 0, square root of 0 is still 0, and 0 times 2 is still 0. So my new graph, notice how I don't have an h and a k, so I'm not shifting this one at all. So its starting point is still at 0, 0, so it's just going to overlap. But now when I plug in 1, I'm not going to get 1 back out anymore. If I plug in 1, don't I get out 2? If you plug 1 into this equation, your answer is 2 now, right? Right? So 1, 2 is my next point. If you plug in 4, what do you get out now? Yes. So now it's 4, 4. And if I plug in 9, I don't get 3 out anymore. I would get out 6. So look what has happened to my graph. It's gotten stretched out.
We got the 6 on the y-axis, but like, where do you get the x-axis from?
Oh, you're plugging in the you can plug in anything you want, but we're plugging in the numbers that are going to be nice square roots.
Okay.
So you want to plug in 0, 1, 4, 9, because they all are perfect squares.
Oh, which one? I see.
Yep. So, guys, what do you think would happen if that number, instead of being a 2, what if it was a 10? How would that make this graph look? Even bigger, right? The bigger this number is, the more stretched out it's going to be. It's going to be it's always going to start at 0, 0, unless I have an h and a k to move it. So this number just makes it get really big. It would stretch everything up. What I'm basically doing is I'm multiplying all of my y values by whatever this number is. So instead of having 1 comma 1, I do 1 times 2, and I got 2 out. Instead of having 4 comma 2, I take 2 and I multiply by 2. That's how I got out of 4. Okay, so whatever that number is, I would just multiply all my y coordinates by that. So it would stretch up. You can also shrink it, right? You could kind of squash the original function down, and that would happen if that number out here was a fraction. So if you multiply it by a half, it would all get compressed, squashed, instead of getting stretched bigger. So, how do you do sort of both things at once? Like if you look at number 6, this has 2 things going on. I have to stretch this graph up to be bigger, right? Because I'm going to multiply it all by 4. And then I also, what does this minus 5 do to the whole thing?
Changes the starting point.
So where would my new starting point be? Perfect. 0, negative 5. So I'm not starting at the origin, I'm dropping it all down 5 units. So if you want my advice, I think it's a little bit too hard to do both of those things at once. So what I might do, first of all, I like to have the parent function on there because I think it's easier to deal with it when I have it right in front of me. Okay, so there's my parent function to start off with. The next thing I would do if I were you is times it all by 4. And then I would just drop it down the 5 units. I think that's your easiest course of action. So if I times everything by 4, I'm still at 0, 0, but now instead of being at 1, 1, I'm at 1, 4. And now instead of being at 4, 2, I'm at 4, what? Where would I be? If I was at 2, now I'm at 8. So 4 comma 8 now. And then 9, that's way off my chart. So here it is times 4. And then I would just drop all those points down 5. I should even do a different color. So this green is my final graph. Does that make sense? Yep.
Do you mind if, like, on like quizzes or whatever we draw that, we just write final?
I don't care how you do it. So if you want to just graph the final graph, if you want to have these other graphs too, that's fine. I don't need to see the other ones. I just need to see the final, but if you want them there. I don't know how you could draw the final without the other two. Personally, I don't know. I need them. Okay, what do we think? We're all right? Let's see. How about you try... Gosh, so many negatives. All right, you try 12, I guess. And then we'll try one with a negative and move on to something else. So you try 12. Put them right in there. Thank you. Sure. All right, guys, we got something for 12. So, if I were you, before I move the starting point, I'd deal with this 5 first. So I would stretch my whole graph up 5, and then I would just move the points accordingly. Okay? So if I'm going to times everything by 5, I'm still at 0, 0, but now I'm at 1, comma, five. I'm at 4, comma, 10. I was at 2, right? So now I've got to multiply it by 5. So now I'm at 410. So I'm already off the grid. So that should be fine. Okay? So, and that makes sense. I knew I was multiplying by 5, so it's going to get much bigger. I'm stretching it up quite a bit. Now, I have to move my point where? My new starting point will be at, what was the first part? I will go down 3. What does this do to it? Yeah, I'm going to go to the right 4 and down 3, right? So I do the opposite of what I see there. So I'm going to take each point. I got to switch colors again. So my starting point is now at positive 4, negative 3. Right? So I shifted everything right 4, down 3. So there's my first point. I'll do the same with the second point. To the right 4, 1, 2, 3, 4, down 3. And my third point, to the right 4, and down 3. I was already over 2, so 1, 2, 3. So this green is my final graph. Does all this make sense? Okay, so what I would like to try is I'll give you a graph and let's see if you can come up with the equation that matches it. Let's see, I think I have some already.
Can we use one of the graphs for these and just like cross out the equations and drawing the graph?
If you want, you don't even have to draw it if you don't want to. But let's give this a shot. All right, let's try this one. Okay, so first of all, what type of graph is this even? Who is the V shape? Yep. Absolute value. So this is an absolute value graph. Okay, good. So I know I'm going to have absolute value bars in it. Have I moved it left or right at all? No. The only thing I've done is move the whole thing up 3 units. Correct? All right. So how would I write that equation? Let's see. I know it's going to have an absolute value in it, so I'm going to have y equals something with an absolute value, and so I know x is in there. All right. How do I show that I've moved it up 3 units and not moved it left to right at all? And then where does the 3 go? That's it. That's your equation right there. Think about it. Wouldn't your starting point be at 0, 3? Yep, it is. And it's an absolute value graph. So I'm happy. Let's try another one. How about this one? See if you can write the equation. Ask yourself, okay, so I see this shape. It's a U shape. I got to figure out who has the U shapes. And then I got to plug in where all those pieces are. I've shifted this one. Looks like it's gone to the left 1, 2, 3, 4, 5 units. Yes, what do you think it is?
Y equals parentheses x plus 5.
You're so close. You just need a squared right there. And then do I need anything else? No, because I didn't move it up or down. Right? All I did was shift it to the left 5. And, right? So remember, if it's in there with the x, I know we moved it to the left 5. That means that h is negative 5. But in your formula, remember the formula looks like this. A times x minus h squared plus k. So in order to make that, if I want to go to the left 5, I need to plug in a negative 5 for h, which turns that into a positive. Whenever you're doing this, right, I would write the equation that I think it is, and then I'd pretend like I didn't know what the graph looked like. And then I would take my equation and say, okay, well, what should that look like? That should be a parabola, and it should have its vertex at negative 5 comma 0. And then I look, oh, yeah, that's right. Because that's probably the most common mistake, is to leave a negative in there. But that would be a vertex at positive 5, 0. So just be careful. Okay, let's try another one. So, what family of functions is this one? Yep. That's a square root. That's the ones we were just talking about. So, see if you can figure out where this one ends up, what its equation would look like. I tell you up in the directions. I know you can't read it. I'm not stretching any of these, so all of these just have an a value of 1. So you don't have to worry about that on this yet. You've got it? Go for it.
Y equals the square root of x minus 3.
Like that? I agree. It's perfect. It's just my square root function, and then I drop the whole thing down 3 units. The only way to do that is to minus 3 at the end. You don't want to put that in there with the x because that's left and right. So up and down is out over on the side. Oh, aren't these fun? How about, let's do maybe one more. How about this one? Oh, sorry. So think, what family of functions is it? Okay. The starting point's not at 0, 0. How'd they get it where it is? And it's upside down. You have it? Oh, excuse me. Sorry. Okay.
Y equals how would you say the negative? Or,
Just like that. I know what you mean.
okay. Minus the absolute value
Yes.
of x plus 3 and plus 4.
Okay, so I'm going to pretend that I don't know what this looks like. So if I were given this graph right here, I would know the following things. Because it's absolute value, it's a V shape. Because it has a negative out in front, it should be upside down. And this one should have a vertex at negative 3, positive 4. Let's see. Are those all those things? Yes. Negative 3, positive 4 is my vertex. It's upside down, V shape. Perfect. Does that make sense? So, I was looking at our schedule, and I was trying to sort of figure out when things were going to happen. So today I was supposed to get through cube and square root. We can do cube roots, they're pretty fast. Monday, I was going to have us do some more practice, maybe some graphing calculator if we have time. And then Tuesday would be our quest on these things. That's my plan anyway. And then the rest of the week we can do probability. So kind of wrap everything up by the end of next week is my hope. If we need to spill on to the next week a little bit, that's fine. And then we'll have a couple days to do whatever you guys choose to do on that questionnaire. And yeah, we'll go from there. Okay. So, what next? What next? Should we do the hard? Yeah, let's do the hard square roots real quick. So I gave you a second sheet that just has numbers 13 to 18. Okay, so if you were looking at 13, I'm going to recopy that over here. Square root of 9x minus 36, and then minus 1. Alright, so just like when we were doing the absolute value, this doesn't fit my form, right? This is supposed to be a 1. I can't have a different number out there. So I'm going to do the exact same thing like I did with the absolute value. So all I have to do is factor out a 9. Oops. You see what I did? And even if it doesn't divide in evenly, you have to force it. But just like I did for the absolute values, I do the same thing. Square roots work the same way in that I can now, once I have multiplication, I can take the square root of them separately. So I'm just going to split this up into the square root of 9 and the square root of x minus 4. I just handle them each individually. But I know the square root of 9, it's just 3. So now I have rewritten my equation to look like something I can handle. Does that make sense? So go ahead and graph that. So that's number 13 now. So we should be able to do that. If you find it helpful to graph the parent function first, I would. You got it? Maybe? So here's what I have so far. The orange is my parent function. And then, because I got a 3 out here, I need to multiply everything by 3. So that's what I did in the black graph, right? Each of my y coordinates is multiplied by 3. And now all I have to do, according to this, is move it where? Yes. So my starting point now picks up and moves to 4, -1. So I need to move each dot to the right 4 and down 1. Yep. So there's that one. So now I take the next spot to the right 4, down 1. To the right 4. 1, 2, 3, 4, down 1. So the green is now my final graph. How'd you do? We okay? So here's the nice thing about graphs, right? I know that there's a lot going on here. You got to remember the parent functions. You got to remember how to move it all around. Well, you do and you don't. If it's test day and you have completely blanked, right, and you can't remember what you're supposed to do, you can literally just keep plugging in points and eventually you will get the graph. So even if you forget everything that I tell you, you can still come up with this green graph knowing nothing else other than, all right, well, let's just start plugging in numbers and see what comes out. If you plug in 0, 0 minus 36 is negative 36. You can't take the square root of that. So you're like, okay, the graph doesn't even exist at 0. Okay, let me try plugging in 1, plug in 2, plug in 3. It's not until you plug in 4 that you actually get an answer, right? If you plug in 4, 9 times 4 is 36, minus 36 is 0. You can take the square root of 0, which is 0. And 0 minus 1 is negative 1. So when you plugged in 4, you got out negative 1. Well, look, 4, negative 1. You just found a point on the actual graph. You could plug in 5, right? 9 times 5 is 45, minus 36 is 9. Square root of 9 is 3. 3 minus 1 is 2. So when you plugged in 5, you got out 2. You can try plugging in 6. It's going to be somewhere in this ballpark, but you're going to get a messy number. But you can still do it. You can plug in 6, you can plug in 7, you can plug in 8. You can fake it till you make it. So if you plug in enough points, you're going to get this. So that is why on a test or a quiz or in anything, you don't ever leave a graph blank. It will take you a lot longer if you just are plugging in points, yes. But you will eventually get it. So there's absolutely no reason to leave graphs blank. No graph should be left blank. You can find a couple of points. You just keep plugging things in and see what comes out. Does that make sense? All right. It is so much faster. Like I could graph 15 relatively quickly because I know what I'm doing. So look how fast. I know it's normally at 1, 1, so now it's at 1, 2. Instead of being at 4, 2, it's at 4, 4. 9, 3 turns into 9, 6. So there's it stretched, and then I just move it right 3 down 4. There, I'm done. So, because I do know these things, it saved me a whole heap of time. But if I knew nothing, just keep plugging in numbers. Eventually, you will get that same graph. Don't forget that. Kids throw away points left, right, and center on graphs. There's no need. Any hoosers. All right, so we're not going to